morning. We are going to be looking at 2.7, which is all about solving rational equations. As we're working through this, you're going to start to see some weird wrinkles in the process, and part of those wrinkles are at times we are going to need to throw out some solutions. So what I want you thinking is about how and why do we reject extraneous solutions? Solutions, squish it. Fabulous. How and why? How do we do it? Why do we do it? We're going to run some from examples. I just pulled a couple from Delta Math, actually, so you may see something that you're going to see later today, and that will be fabulous. Here's our first one. It looks like this. X over x minus 1. I'm going to clean that up a little bit. Sorry. X over x minus 1 plus 8 equals 1 over x minus 1. So immediately, I hate fractions. Like, that's something you just need to know about me. And I know it sounds funny saying that I'm a math teacher and I hate fractions, but I don't like dealing with them. My brain doesn't enjoy them the way it does nice, beautiful whole numbers like that 8 in the middle. So here's what I'm going to do. My job is going to be to clear out the fractions as quickly as possible. Okay? So what I'm going to do is I'm going to look at the denominators along the way and build my lowest common denominator. So my first denominator is x minus 1. The 8 does not have a denominator, which is fine. I like that 8 for that reason. And then my 1 over x minus 1. Now, x minus 1 showed up 2 times, but I only need to include it once in my LCD because the 1 from the first denominator kind of covers the 1 from that last fraction after the equal sign. Now, I am going to multiply every term by that x minus 1. And the reason I do that is because, remember I said I hate fractions? By multiplying by x minus 1 in a spot where I'm dividing by x minus 1, they cancel. On the 8, they just kind of link up, but then again in the back they cancel. I'm left with just 1. Now look at that. It's beautiful. There's no fractions. We are #blessed. So here we go. X plus 8x minus 8 equals 1. Like terms, add 8 to both sides. X equals 1. If you need to see that in a little more detail. There's some kind of yellow markings to help guide your thinking. So my final answer was x equals 1. But now we have to check it. Does an answer of x equals 1 cause a denominator to be 0? And the answer to that question is yes. So what we do is we reject x equals 1. It is an extraneous solution. Okay? So we don't actually have a solution here because the one we came up with is what's called extraneous, right? It makes a denominator equal 0. 1 minus 1 for my denominator equals 0. That's kind of a bummer way to start, so let's give this another go. Let's do another example. -6 over x plus 2 minus 8 over x equals -2x over x plus 2. The first thing we are going to do is we are going to build our LCD. First of all, I see an x plus 2. Okay, great. I've accounted for the first fraction. But then I see an x. And then I see another x plus 2, but x plus 2 right here is already in our LCD. So I don't need to include it again. It's been represented. So I don't need to all of a sudden say, wait, write it again. No. It's already there. It's already captured. So we're going to take that LCD, and every single fraction is going to get hit by it. In the first fraction, the x plus 2's cancel. In the next fraction, the x's cancel. And then the third fraction, the x plus 2's cancel again. So here's where we're at. We've got a -6 and an x, a -8 times an x plus 2, and a -2x times an x. So we're looking for what's left standing after everything's been canceled. And now our job is to solve this equation. Okay? So we start with the distributive property. Now I'm going to do one thing to start us off. When I have x squareds and x's in the same problem, I want everything on one side of the equal sign. So I've got 2x squared minus 14x minus 16. And now I can set one side equal to 0, which is so nice. It's nice to have that option because then it allows us to do some factoring. So first thing I'm going to do is I'm going to factor out a 2 and get x squared minus 7x equals 8. Okay? Which means my final answers are 8 and x equals -1. Okay, so we did lots of things here. So I'm gonna go back and kind of talk through it. The first thing we did is we said every single coefficient here is divisible by 2. So I'm gonna pull a 2 out to the front, just to make it easier to look at. And then I'm gonna ask myself, what multiplies to -8 adds to -7? I'm gonna say, oh, -8 plus 1. And that's how I filled in the parentheses. But then x lies, so my final answer is x equals 8, x equals -1. Now I check for extraneous solutions. Remember, does either solution cause the denominator to be 0? So check. X equals 8. We're good, fam. Check x equals -1. We're good, fam. If this problem was going to have an extraneous solution, it would either have been -2 or 0. Both of those are fabulous. So this one has no extraneous solutions. Let's finish off with one more question. Hopefully you're doing great things, listening, following along, making the magic happen. Here we go. 1 plus 3 over x plus 9 equals x over x squared plus 15x plus 54. Now, everything we've done has started with find your LCD. But before I can find my LCD, I need to understand what's happening in my denominators. So the very, very, very first thing I'm going to do is I'm going to look at this last denominator. I'm going to say, let's rewrite it. What multiplies to 54 adds to 15? Plus 6 and plus 9. Why is that so much more helpful? Well, as I build my LCD, the first denominator I run into is an x plus 9. Right? That's right here. Well, if I didn't know that the last denominator was able to factor the way I factored it, I wouldn't have ever said, hey, x plus 9 is already covered and I might include it again, and I wouldn't get to see all the canceling that's possible. So as I build my LCD, the x plus 9 shows up in both denominators. And so instead of doubling up, I'm just going to make sure I lump it together and include it. So that's an interesting piece, and that's why we do this factoring step to start, okay? So start by factoring. Now, we haven't had one that has needed to be factored yet. So that is something kind of a new wrinkle that we have in this particular problem, was that we had to factor it because we couldn't see what we wanted. And so we had to address that little bit of a wrinkle. Okay. Once we have our LCD, that's the same. We still multiply everything by that LCD. And we still look for what cancels, right? I see that in the first thing, nothing cancels. Here, the x plus 9 cancels. And here, everything cancels. So here's what we've got. That's what I'm seeing. And that's the equation that we're going to work towards solving. How did I know that that's what that was going to be? How did I know that x plus 6 and x plus 9 multiplied to make x squared plus 15, x plus 54? Now don't say, because you're the math teacher, Visto. No! I know where x plus 6 and x plus 9 came from, right? It started in the bottom, and now we're here. So I factored it to understand it. Unfortunately, I get to kind of unfactor it and use it again back at itself. Anyway, plus 3x plus 18. Gotta love the distributive property. Now we're here. Right? All that multiplying with the LCD is going to create a new equation. So x squared, I'm going to collect all my like terms. By collecting my like terms, now I can have a little bit easier equation to look at, but I still need to move this x over. If you have x squared and x in the same problem, set one side equal to 0. In other words, move everything onto the same side. Factor again. What multiplies to 72 adds to 17, 8 and 9. X plus 8, x plus 9 equals 0. And then use your factored form to determine your solved form. Okay? Finish with a check. Check. X equals negative 8. Does that cause problems? Nope. We're good. X equals negative 9? Yes. That's a problem, right? X plus 9 was in our LCD. X plus 9 was in our denominator. X equals negative 9 is extraneous. So we reject x equals negative 9 as an answer. And really, we want to say that x equals negative 8 is the answer we care about. So I know I got this a little bit long because there's 3 examples, but I really want to show you lots of pieces. Take some time, watch this. I really hope you get to use some of this as you go through your Delta Math. I hope one of these shows up. But you got this. I believe in you. You can crush it. Ready?